So now let us quickly discuss about the target case sum problem. So you you will be presented a problem statement like this, or otherwise in some cases you will be directly presented sample input list and sample output list. So some of its variation may include that if any of the two of the digit is reaching to the key, then you simply need to return either boolean, or in some cases you are expected to actually produce all of the element that is actually reaching the k value, right? K target. Or in some cases you are expected to return, instead of this element you are expected to return the indices. We'll discuss all of its variation. I believe that this particular problem statement, like wherein we are outputting the complete element, this addresses all of the variation also, and you can easily implement the rest of the variation accordingly. All right. uh, so basic explanation, I hope are you are getting a sense that over here we need to find out if any of the two elements within the list is reaching the target k. For us the k here is 7, so 1 plus 6 becomes 7, 2 plus 5 becomes 7, 3 plus 4 becomes 7. We also need to make sure that none of the element is repeating, right? So I'm currently discussing a non-optimized approach. There is one optimized approach also, we'll come to it a bit later. First let us focus on the this output and the indices output. So for this what we need a processing set. Let's call this p set. Let's have one resultant list that holds this whole thing, right? Apart from this, I'll come to whatever things that we may need later. So my logic goes that what you can do, you iterate, you begin keeping the first element as constant and you compare it with the rest of the element, right? And then in the second iteration you keep this element as constant and you compare it with the rest of the element. If any of the summation is reaching the k value, you put this in your processing set and you just check that this particular combination is not directly, is already not processed. If it is not processed, then you move ahead and put this in your resultant list. Okay. It will make much more sense when I start implementing it. So we'll begin with for idx comma pval. So for us the pval is the constant part that we want to keep. So for first iteration it will be 1, for second iteration it will be 2, for third it will be 3, and so on. In enumerate input list, right? Let us decorate it with function actually, because that is what is expected in every interview also. Yep. Okay, so we'll begin now. The reason I have used this enumerate, because I want to, like, when I'm iterating, keeping the first as constant, I want to for my inner indexes, for my like I will be using an inner loop over here, and that loop will traverse to all of the element except the element that I want to keep it constant. So for us the p val will remain constant and the rest of the element will be traversed. So we do inner list is equal to input list of idx plus input list of idx plus 1. So what this will do, this will keep all the this will consider all the element up to the current p-val element, and this will consider all the element after the p-val element, right? So basically p-val element, for first iteration one is removed and all the rest of the element is considered. For the second iteration two is not considered, all the rest of the element is considered. This is how the inner list is forming. Now we iterate inside this. for ival in uh, this inner list. Now what we need to do, we need to simply do the comparison, basically the summation, and check whether it is reaching the target key. So for that we also need target key, and target key is here 7, right? So now for if pval plus uh, ival equal to target key, right? So now what you do, you create the current combination. So here what we need to do, we create the current combination as a list pval comma ival, and we sort this just to avoid any duplication in the later iteration. If the same combination may happen, we will avoid it, right? Now we also need to consider that if already this thing was already processed, we do not need to process it now. I am personally in favor of using set. So you cannot directly insert the list inside the set, that's why we need to create a tuple out of it, right? So the tuple will become current combo tuple is equal to tuple of current combo. Okay, now we simply check if current combo tuple is already inside the preset, right? If it is not inside the preset, we can move ahead and we can include the result list as current combo tuple, and we also need to consider inserting preset dot add current combo tuple. That's it. That's what that was it about the target case sum, right? I'll execute this. My bad. We need to return something, so let's return resultant list. Okay, this is achieving the end output that we wanted. A quick rebrief or a quick revision. This target KSM is basically trying to find out if any two element is reaching the target k, and there are various variation. If any two is reaching, you either will be expected to just return boolean true or false. In some cases you will be expected to return the element. In some cases you will be expected to return the indices of this element. So currently we are checking the element variation, and through this you can come like create all the rest of the variation. So we begin by creating a target case sum function. Inside this function our main logic lies that we keep the parent element as constant, and we traverse to all of the inner list element, right? And if parent element plus any of the inner list element is actually reaching the target k, we just create the combination of it in the sorting order to avoid any duplicate. We create a tuple, uh, and we check whether this tuple is already present inside the process set or not. If it is not, we move ahead and we in like add it into the resultant list, right? Now I'll just copy paste this as the extending as the next variation is just the extending part of this. So here with the element, you are also expected to return the indices of it. So most of the things remain the same. At the same time, what you can do, you can implement a closure like function over here, or you can implement a function at the top level. Both of this is fine. I'll lean towards a closure function because this is like quite relating to the target case sum only. The indices belongs to this target case sum problem. So here I create find indices. We have input list, right? We traverse for indices comma for index comma element in input list. We should create a dictionary, so this will have like uh, element idx info. Now this will have element idx info of element is equal to idx, right? So after this thing, whenever you call this, you will have a dictionary. This dictionary will have the element. So for example, 1 will have a value of 0, 2 will have a value of 1, 3 will have a value of 2. Return element index info, right? Now before calling anything, we can have this return element index info is equal to find indices input list. All right. The rest of the code remains same. It's just that while you are doing the result list and this operation here, you should do, sorry, here you should create another list as a result idx list. This result idx list will append things, and this is expected in the form of tuple. For instance, you can have list also. It is just by convention I am using the tuple. Now here you already have the index info, so from index info you pass on the key will become pval, and element index info key will become ival. You can use the sorted function, right? And you can return this result idx list. Let me destructure it. Result list comma result idx list. Let me print result list. Let me print result idx list. Target key is sum with idx non optimized. Something is broken. Let me just check. I forgot to write enumerate here. A quick scan. I think so. This should work. Let's see. Okay. Made a slight mistake here. This needs to get wrapped as this because sorted expects only one element. Right. So this is this thing, and because we need by convention a tuple, we can decorate it with tuple. I think so. Now this should work. Yeah, this is working, and this is was the expected output, right? So I hope this thoroughly give you a brief about target ksum problem. It is quite an important problem to solve. If there is indexes variation, you just need to consider that you create one closure function or any function that is residing above this function. You get the index info of each and every element, right? Now the whole logic remains same. It's just that while doing the result list append, you also do the result idx list append in this manner. Now that we are aware of this whole how this thing is functioning, there is still a scope of optimization. As we can see, there are two loops, and the time complexity here is reaching the n square, right? So we can optimize it a bit by using basic logic. What we can do now that we are already utilizing this find indices and we already have the info in the form of dictionary, the core logic of this optimization revolves around whatever parent element that we have, we subtract it with the target k. Whatever is the value that we get as a remainder, we try to find out if that is already present inside this dictionary. If that is present, then we simply can consider that as a combination, and we can put this in our resultant list. So let me just copy paste this Let me do the complete override. Yes, let's get rid of all of this. Yes, so here we begin with again pval in input list. Here we declare a variable called as remainder. This variable will have this positive value abs, because we are not interested in whether we get a negative or positive. We are only interested in getting whether it is reaching the target key either from negative or from the positive side. So pval minus the target key. So in this case, the target key is 7. So 1 minus, consider this, 1 minus 7 will give us a value 6, and 6 is already present inside the dictionary. The key will have the 6 value, right? So if it is already present, we simply need to check if remainder in element index info. We can utilize the p set to avoid the duplication, and the rest of the logic follows the same. So here we create the current combination combo tuple, let's say, and here we have pval, comma, whatever is the remainder. So this becomes our current combo tuple. We can check now if current combo tuple not in p set. We move further. I have made some mistake here. Sorted is not closed. Yes, right. This is not there, so we can simply do result list dot append current combo tuple. We also need to maintain the result idx list. So this also we can do in the similar fashion as we did in the previous case. We apply the sorted function to a list. We get the element from the element index info list, pval, and the second element will be remainder. You apply the tuple, and we finally apply to the p set current combo tuple. Right now, if I execute this, optimized, this is functioning fine. We have received the output 051423 and 162534, and yeah, we have optimized our whole algorithm from this complexity to this complexity. I hope this whole session was useful for you. Thank you.